Okay, so today, let's see where we are. All right, so far we have been looking at summarizing data, summarizing data. All right, we said that we could summarize data using the center, and we learn about measures of central tendency. We learn about the mean, we learn about the median, we learn about the mode, and then we learn other things like weighted mean, and weighted means. Weighted means. All right, weighted means is the way you calculate your GPA and all those things. Now, in general, I indicated that in summarizing data, you're looking at what is that one number that can be used to as a best representative of the group. Now, I also indicated that the mean was not enough because you could have two data sets that have the same mean, same standard deviation, same mode, same median, and for that reason, you want to know how spread out, how spread out the data is, right? So we also now started learning about measures of variability, and we said the word can be variability, the word can be variation, the word can be spread, measures of spread, the word can be dispersion. They all referring to the same thing. Here you are looking at how spread out the data values are, right? So these are all the same, meaning the same thing, right? So the words are interchangeable. I can say measures of variation, or I can say measures of spread, or I can say measures of dispersion. I'm referring to the same kind of measures. Now, we indicated that the four most common measures are the range, which we learn is the highest, minus the lowest. We learn about the variance, which is the average of the squared deviations, and then we learn about the standard deviation, standard deviation, which we said you can get a standard deviation by taking the square root of the variance. We show that. Right now, these were three of them. There was one more that is called the interquartile range, popularly known as IQR. All right. We haven't spoken about this one, but we've done the standard deviation, we've done the range, we've done all these three. Okay. We will be looking at the interquartile range on Monday. All right, we'll be looking at the interquartile range on Monday. Now, what we will be doing today is to look at what are the different situations where, what are the different ways we can apply, the standard deviation. So today we are going to be focusing on application of the standard deviation, application of standard deviation. That's what we're doing today. Specifically, we'll be looking at four areas. All right, using comparing standard deviations. Number two, we're going to look at something called the empirical rule. Number three, we're going to look at something called the Chebyshev Theorem. And then four, we're going to look at something called z-scores. All right, so these are all ways in which we can apply the standard deviation. All right. So ways of applying the standard deviation in comparing in what we call empirical rule, in Chebyshev theorem, and then in z-scores. So those are the things we will cover today. So the online assignment you'll be given will relate to these questions. All right, questions about comparing, questions about empirical rule, questions about Chebyshev theorem, and questions about uh, z-score. Then on Monday we'll focus on the interquartile range. Okay. So let's start with the idea of comparing standard deviations. All right. So standard deviations, now it makes a lot of sense when we think about social distancing, right? So we should be apart, a little some inches apart from the other person, right? So if you are far apart, then the social distance will be large, right? If you are very close, the social distance will be low. So in the same way, the standard deviation, I just coined the term value distancing or values distancing, right? I don't know. Okay, so when we look at the diagrams here, the diagram we have here, we could see that data set B, they are very close, they are very much closer to each other, right? Data set C is far, very far. So this high social distance, this is low social distance, right? This is relatively somewhere in between, right? So when you look at the information, even though they have the same mean, the mean is the same for all three of them, we can see that um, set B, data set B has the lowest, right? They are very low social distancing, right? Low standard deviation, low social distance. Well, it just happened to rhyme nicely. All right, they are very low standard deviation. Then when you look at A compared to C, A, um, the value, the social distance or standard deviation for the A, it's lower than the standard deviation for C, because C has very high social distance. Like when you look at this group is far apart from this. So extremely much. So we expect the standard deviation for group C to be higher than the standard deviation for group D. So which means that if I give you three charts like this, that, and I give you the standard deviation, the social distance values, you should be able to match which one goes with what. All right, you should be able to do a matching of this. Now there's also some graph here I want to point out. So when you look at this diagram, right, if all the values are the same, if all the values are the same, 5, then the standard deviation is 0. All right, there is low social distance here and there is high social distance here. So the standard deviation in this place, the standard deviation over here is kind of higher than the standard deviation over here, because these things are close together, these things are far away, far apart from each other. Okay, so that's one way we can apply the standard deviation, is by comparing the standard deviation. Okay, so that's one thing I wanted to point out. The second way we can apply the standard deviation is through what we call the empirical rule. All right, the empirical rule. The empirical rule is also popular known as the 68, 95, 99.7 rule. All right, so when we talk about empirical rule, it's also known as that. Now, in general, the empirical rule tells you, the empirical rule tells you about the percentage of your data values that lie within K. Let me say within K standard deviations. Within K standard deviations. For example, The first rule of the empirical rule says that 68% of your data would lie within one standard deviation of the mean. So 1 here means your k is equal to 1. Now, when we say within one standard deviation, this is what we mean. First of all, the empirical rule is only about a bell-shaped distribution, all right, a normal distribution. So empirical rule only true for bell-shaped distribution. I need to indicate that because that's a very important statement. All right, the empirical rule is only for bell-shaped distribution. Now, so one only for bell-shaped, or we call normal distribution. All right, the empirical rule is only for bell-shaped normal distribution. Now, the second statement says that 95% of your data will lie within 2 standard deviations. All right, so here your k is equal to 2, and then the third statement says that 99.7% of your data will lie within 3 standard deviation, which means that here your k is equal to 3. So in terms of the empirical rule, when k equals to 1, the percentage is approximately 68%. When k is equal to 2, the percentage is approximately 95%. And then when k is equal to 3, the percentage is approximately 99.7%. So know these things about the empirical rule. All right, it is only for bell-shaped distribution, and 2, when k equals to 1, the percentage will be approximately 68. When k is equals to 2, 95. When k equals to 3, 99.7. Now, k is the number of standard deviations. All right, it is not the standard deviation itself, it is the number of standard deviation. All right, now k, if you don't know k, you could obtain it by taking the value minus the mean divided by the standard deviation. All right, if we don't know k, we can obtain k by taking a value minus the mean divided by standard deviation. Very soon you would see that this could be talked of as a z-score. Okay, all right, so let's see how we could apply the empirical rule. So number one, I've indicated to you that empirical rule is only for bell-shaped distributions. All right, now so let me label this as A space B space C space D space E space F space G and then space H. So for every bell-shaped distribution, right, we can split that into 8 spaces from A to H. All right, now the first space here, space D and space E, is what is k equals 1 and then k equals 1. So when k equals 1, it means within one standard deviation. That's what k equals 1 means, which means that it's one standard deviation to the left of the mean, one standard deviation to the right of the mean. So another way to think of it is that when k equals 1, the lower limit is the mean minus 1 times the standard deviation. The upper limit is the mean plus 1 times the standard deviation. So if this is the mean, then this is x bar plus x, because one standard deviation, then this is x bar minus x is that. Now, because k equals to 1 is 68%, then d is going to be 34%, and then e is going to be 34%. So the two of them together gives you 68%. All right. So when k is 1, the percentage is 68% of your data. Okay. Now, when k is equal to 2, all right, the percentage is 95% of the data. Now, in our diagram, when k equals to 1, for example, we are referring to the space what? D and E. Space D and space E. But when k is equal to 2, let me show you where. So k equals to 2, that's the second line on the left to the second line on the right. When k is equal to 2, we are referring from what? C, D, E, F. All right? It's from C, D, E, and F. C, space D, space E, and F. All together should give you 95%. So the amount of data that should be in that range will be 95%. Okay. We already know that B, D, and E alone is what? 68%. These two is 68%. All right, so we need C and F. So what you're going to do, take 95, subtract 68, that will give you 27. And then divide the 27. So 27 divided by 2 gives you 13.5. So C is 13.5, F is 13.5. All right, so that's how this 13.5 was obtained. Now, when k is equal to 3, the percentage is 99.7%. Now, what does it mean? It means that you are looking at from what? B, C, D, E, F, and then G. All right? You are looking from B, C, but we know from what? From C up to F, from C to F, from C up to F, it's what? 95%. So you're going to do 99.7%. So now we need to know what is B, what is G, right? What is B and what is G? So subtract 95, that gives you 4.7. Then do 4.7 divided by 2, that gives you 2.35. So G is 2.35, and then B is also 2.35. So this is 2.35, this is 2.35. When you add it, you're going to get 99.7%. Then finally, we know that anything beyond k equals to 3, everything from A to H is 100%. All right, so if you want A and H alone, remember that when we take 100% minus 99.7, the answer will be 0.3%. Then when you split 0.3% into 2, you're going to get 0.15%. So that is why A is 0.15% and then H is 0.15%. So take note of these. Okay, now, so this is how empirical rule questions are. For example, this question says you have a bell shape and it says use empirical rule. So once it says use empirical rule, use 68, 95, 99.5% rule. That's what it means. All right, so the first thing to do is to draw the curve and put all the percentages on it. So A, B, C, D, E, F, G, H. Put all the percentage on your curve. All right. Then use that to answer the question. So they said from 88 to 115. Before you do the question, they told you that the mean is 100. So at the middle, you're going to put 100 in the middle. Now, every space is a standard deviation. Every space is, all right. So you're going to say 100 plus 15 will give you 115. 115 plus 15 gives you 130. 130 plus 15 gives you 145. Now 100 minus 15 gives you 85. 85 minus 15 gives you 70. 70 minus 15 gives you 55. So that is how the numbers are obtained. All right, that's how the numbers are obtained. Then the question says from 85 to 115. 85 up to 115. So here you are looking at what? 85 to 115. You are adding D plus E, and that would be 68%. Now the next one says from 70 to what? To 130. So you are adding from 70. So C, you are adding C plus D plus E plus F, and that will be 95%. The third one says from 55 to what? 45. So you are adding from A to G. From A to G, that gives you 99.7%. Now, the next question is a little different. Now, the next question says, find the percentage from 70 to 115. From 70 up to 115. So add the percentage. So that would be C plus, so that would be C plus what? C plus D plus E. C plus D plus E. All right, I don't know what the answer would be. Now the next one says greater than 115. Greater than 115 will be what? F plus G plus H. Greater than 115. So everything 115 and above. All right. Then the last question says less than 70. Less than 70. So this is 70. So it means only A plus B. Right. Less than 70 is this area. Less than 70. Below 70. So you're looking at A and B. All right. So all you're doing is basically to add the percentages. All right. To add the percentages. And that's what I've actually shown on the slide here. So that is how to do problems that relates to empirical rule. All right, those are problems that relates to empirical rule. Now, so let me recap. We said application of standard deviation. We can use it for comparison. We can use it to do the empirical rule, which is the 68, 75, 99.7 rule. Now, we can also use that for what we call the Chebyshev's theorem. Now, the Chebyshev theorem is very similar to the empirical rule. The Chebyshev theorem is very similar to the empirical rule. The only thing is that whereas the empirical rule only focus on symmetrical, the empirical rule is only used for symmetrical distribution that looks like bell-shaped or normal distribution. All right. The Chebyshev theorem can be used for any distribution regardless of the shape. All right. So it could be any distribution. The shape could be skewed. Oh, what happened here? Okay, sorry about it. The shape could be skewed. The shape could be anything. All right. So Chebyshev is for any distribution. All right. Empirical is only for symmetrical. Chebyshev is for any distribution. Once again, it's looking at what the minimum. So empirical Chebyshev is looking at the minimum percentage of data values within k standard deviations. So it's looking at what is the minimum percentage of data that lies within a certain k number of standard deviation. All right. So here, once again, the k is the number of standard deviations. Standard deviations. Now, the number of standard deviations is different from the standard deviation itself. Think of it as quantity. All right. This is like quantity, the quantity of something, the number of standard deviations, right? For empirical rule, so I'll say, so for Chebyshev theorem, k is always greater than 1. All right. K is always greater than 1. All right. And k can be a fraction or decimal. In other words, whereas empirical rule only deals with k equals 1, 2, and 3, Chebyshev can be any k greater than 1, and it can be fraction. It can be 1.1, it could be 1.9, it could be 2.8, it could be any fraction greater than 1, any number greater than 1. All right. And because of that, the Chebyshev, there's only important word is that it deals with the at least the minimum percentage of the data that lies within a particular k. All right. So the proportion can also means the percentage of any data set lying within k standard deviation. K is greater than 1. According to the Chebyshev, right, the percentage, you can get it by doing 1 minus 1 over k squared, and usually to get a percent you multiply it by 100. So anytime we talk about Chebyshev, think about this formula. Now, so when k is equal to 2, you're going to do 1 minus 1 over 2 squared, which is 1 minus 1 over 4. This is 3 over 4. This is 75%. So we're going to say that when k is 2, at least 75%. So when k is equal to 2, at least 75% of your data lies within that. Now, what about when k is 3? Then you're going to do 1 minus 1 over 3 squared. This is 1 minus 1 over 9, which is 8 over 9. That is 88.9%. So when k is equal to 3, at least 88.9% of your data will lie within 3 standard deviations. All right. Don't forget that in Chebyshev, k can be any value. All right, greater than 1. K can be any number greater than 1. But I want you to memorize this for Chebyshev. So I would say for Chebyshev, when k is 2, at least, the word at least or the word minimum should always come with Chebyshev. 78%. When k 75%. When k is equal to 3, at least 88.9%. All right, this you got to memorize that or remember it for Chebyshev. All right, 2 that 3 this at least. And Chebyshev always go with the word minimum or the word at least. Always. Okay. Now, so how do we answer questions that relates to Chebyshev? Um, how do we answer questions that relates to Chebyshev? Let me see here. Now, for most questions, let me tell you what would happen. Anytime you're doing Chebyshev, think of a triangle that has the vertices means three things. This side could be percentage, the minimum percentage. This side could be K, and then this side could be the limit. Now, limit, we have lower limit, and then you have upper limit. Okay. Now, for all Chebyshev questions, they can say that, okay, this is the percentage, what is a K? Or they can say, this is the K, what is the limit? All right. So it could ask you either about minimum percentage or about K, but usually you'll be given one of these 3 points. Okay. So in this question, for example, they said the percentage is at least what? 75%. Now, if the percentage is 75%, then we expect the K to be what? 2. If the percentage is 75, this is given, then you can imply that because it is Chebyshev, all right, in general, Chebyshev is for any distribution, all right? So if the percentage is 75, so if this is given, if the percentage is given, we can imply that then the K is 2. Now, when you have the K, that can help you find the limit. You can use the K to find the limit. Now, the question is, how do you find the limit in this case? The lower limit, because it says you should find between where the two values will fall. You should find between where the two values will fall. The lower limit is always the mean minus K times the standard deviation. All right, so write this formula down somewhere. The upper limit is the mean plus K times the standard deviation. So in this case, let me draw a line here like this. So when K equals to 2, K equals to 2, the mean is always in the middle. So the mean, they said, is this, right? The mean is 52.4. The lower limit is the mean, so x bar minus K times the standard deviation. So we say 52.4 minus 2 times standard deviation is what? 2.2. 2.2. And when you work this out, it's going to give you 48. Then the upper limit, it's x bar plus K times standard deviation. So here, so this is a lower limit. So the upper limit will be 52.4 plus 2 times 2.2. So that will be 56.8. That is the upper limit. This is the lower limit. All right. So what you see here is that when they give you the K, you can use the K to find the lower limit and then to find the upper limit. So see what happened. They gave you only the percentage. All right. You use a percentage to find K. You use K to find the limit. Right. You use K to find the limit because there's K inside the limit. Right. There's K inside the limit. And then the mean is given, the standard deviation is given. So you just plug in that way. Okay, so you know what? Let me take some questions at the bottom here first. Okay, so let's quickly look at some questions here before I go to the next stage. Okay, so the Chebyshev is applicable to what? Any distribution. All right. The empirical rule is applicable to what? Only bell-shaped distribution. Then this says the Chebyshev states that the percentage that fall within 3. So Chebyshev k equals 3 means at least 88.9%, which happens to be 88. This is wrong because it should say at least or it should say minimum. All right. Empirical rule. Empirical rule. That is the 68. Remember, empirical rule is 68, 95, 99.7. This is k equals 1, k equals 2, k equals 3. So they say within 2. So k equals 2 for empirical. When k is 2, that is C. K equals 2 is C. Now, Chebyshev. This is Chebyshev. And they say 2 standard deviations, so k equals 2 for Chebyshev. When k equals 2, now here they've used the word minimum already, so we are good. Anytime they talk about Chebyshev, the word minimum or at least should come. So when k is 2, that is 75% for Chebyshev. That's why I said memorize the k equals 2, k equals 3 Chebyshev. Now this says Chebyshev, but then k equals what? K equals 3, k equals 3, k equals 3. Chebyshev, k equals 3. They've already mentioned about minimum. All right. So when k is 3, that is this, which is what? 88.9%. Okay. Now let's see another one. Now this one says that Chebyshev, but this time k equals to 2.5. This you don't know. So remember to find the percentage. I said when they gave you k, and then they can ask you to find percentage, right? When they give you k, they can ask you to find percentage. So if they ask you to find percentage, then you got to use the formula 1 minus 1 over k squared. So you're going to do 1 minus 1 over 2.5 or squared. I don't know what this will give you. I'm suspecting that will be like 84, but I'm not too sure. You can check it out. All right. Empirical, and then they say 1 standard deviation. Empirical is 68, 95, 99.7. This is 1 standard deviation. This is k, sorry, this k equals 1, k equals 2, k equals 3. So that would be 68%. Okay, now let me actually do one more here because we have to cover one last thing on this one. All right, now this is an example where they gave you the mean. So mean is 43. Standard deviation is let me write S. Let me write S for standard deviation. So S is 6, right? They gave you lower limit, percentage K, and then the limit. So this time they gave lower limit is 25, upper limit is 61. All right. Now, if they give you the limit, you have to find K, and then you have to use a K to find K, and then use a K to find the percentage. All right. If they give you the limit, then K is the upper limit minus the mean divided by the standard deviation. So in this question, you're going to do 61 minus 43 divided by 6. Could someone work it out for me? In the second question, lower limit is 31, upper limit is 55. So K What do you get? 3. So if K is 3, then we're going to select that because K equals to 3. Now in the second question, the lower limit is this, the upper limit is that. So we say K will be 55 minus 43 over 6 again. I'm suspecting this will be 2. I don't know. Someone check for me. So K equals 2. That will give you that. Thank you. Okay. So that is how some of your online assignment will look like. All right. These questions, most of it are in your online assignment. Okay. Now, remember I said that we can apply the standard deviation in 4 different areas. The last part that I want to talk about is called the z-scores. All right, the z-scores. And let me quickly go through that, the z-scores. The z-scores is also called the standard score. All right. The formula is a value minus the mean over the standard deviation. If the z-score, so it tells you how many standard deviations, the number is, so it tells you the number of standard deviations above or below the mean. So the z-score is like K. All right, it's like K. K is a value minus a mean over the standard deviation, same as a z-score. So it's the number of standard deviation above or below the mean. Now, so if they give you the question and the question says find z-score, all you got to do is to use a formula: value minus a mean, value minus mean divided by standard deviation. That's all you got to do. All right. So here, for example, if they said the value, the score is 85. So the mean is this, the standard deviation is this, the score is that. So you're going to say 85 value minus the mean over standard deviation. If that gives you 1, because this is positive 1, you would say that the score is 1 standard deviation higher, or the word higher could be above the mean. Okay, now the next one, for example, says the score is 70. If the score is 70, so you have the information here: 70 value minus the mean over standard deviation. That will give you negative 1.4. Now, because it is negative, you're going to say that that score, the score of 70, is 1.4 lower. Now, here the word lower means below, means below the mean. It's 1.4 standard deviations below the mean. Okay, now we use the z-scores to compare your performance in 2 different classes, maybe your math class and your English class. So let's say John scored 75 on the test. The mean is this, the standard deviation is that. So John alone, John's z-score will be the score minus the mean over standard deviation. So this is John's z-score. Now note that John is so 0.4 standard deviations above the mean. Now let's look at Sam. Now Sam's z-score, Samantha, she scored 68. The mean is 65. The standard deviation is that, right? So this is Samantha's z-score. So when you put it on the number line, for example, if this is 0, then 0.4 is here, then 90.92 is here. So this is Sam and this is John. Now 0 is like the average of the class. All right. So Sam performed better than John because Sam is far away from the 0, from the average. All right. So Sam's score is better than John. Sam's score is better than John. Now let's look at another example. Then I'll stop here. So in this example, we are looking at John and Ali this time. We are looking at a GPA because their school has different GPA system. All right. So in John's class, John has a GPA of 2 point that. So this is John GPA. The school mean is 0.3. The school standard deviation is 0.7. So this is what John scored. All right. So let me draw a line here. Suppose this is 0. 0 is the average. Maybe negative 0.21 is here. So this is John. Now Ali scored 77. So Ali scored 77 minus 80 over Ali's average. So Ali is negative zero point 0.3. Now negative zero point 0.3, it's here. This is Ali. So who did better? John is, even though they both score below average, John is closer to the average than Ali. So we're going to say that John has a better GPA compared to Ali. Okay, so I'm stopping here and I'll give you some online assignment. Oh, by the way, let me mention this before you go. Any z-score that is below -2 or z-score above -2, it's seen as unusual. All right, it's seen as unusual. So if you take a test in a class and your z-score is below -2, it means you did very bad. If your z-score is above +2, it means you did very well. All right, so let me stop here and I would give you the assignment. This is already recorded and I wish you all best rest of your weekend, and I'll see you